All right, we're going to take a look at some more applications with ratio and proportion. And we're going to form the relationship between the unit rate as a constant of proportionality. All right, here is our first example. It is on your lesson worksheet, so you can read it off your lesson worksheet. It's the same thing. Wildlife conservationists are concerned that the deer population might not be constant across the national forest. The scientists found that there were 144 deer in a 16 square mile area of the forest. In another part of the forest, conservationists counted 117 deer in a 13 square mile area, and yet a third conservationist counted 24 deer in a 216 square acre plot of forest. Do conservationists need to be worried? All right, so on your lesson worksheet, and again, these actual questions you can just contemplate. If there's something, again, that is important or something you didn't know or you want to write down for later as part of your studying, then please write it down in your math journal. So why does it matter if the deer population is not constant in the certain area of the national forest? And basically just stop and write down or think about why would it matter? And basically any theory is acceptable. So right now it's just to kind of add some reasoning to why this would be important. All right, so we're going to start off, make a table of the ratios and their unit rate equivalent. So that you can do on your lesson worksheet. You should have space there to do that. So identify the ratios and then also determine what is the unit rate between each one of them. When you're done with that, go ahead and continue the video. Alright, so what is the population density of deer per square mile? That should be the same as your unit rate. Your table should look something like this. So square miles, the number of deer or the number of deer in the square miles. It doesn't matter in that particular instance what the order is, but then your third column should show the unit rate. So since we want to know how many deer per square mile, it would be set up like this: 144 over 16, 117 over 13, and 216 over 24. All right, when we find the number of deer per square mile, what is this called? And you can, again, any of these questions and answers you can write in your math journal. You don't need to write them word for word, just anything that stands out. Well, we call this the unit rate, which we just kind of hinted about before you answered the question. So when we want to know the number of deer per square mile, remember 1 square mile is the unit, that is what we call the unit rate. When we look at the relationship between square miles and the number of deer in the table, how do we know if the relationship is proportional? So look at your table. How do you know that? First of all, is it proportional? And if so, how do you know? Well, the square miles is always multiplied by the same value, which is 9 in this case. So again, the relationship between the square miles and the number of deer, the difference between that is the fact that square miles is multiplied by 9. Not the fact that it's a division problem. We need to think of this relationship as a multiplication problem. And what number is multiplied constantly? The number of deer is multiplied constantly by the number of 9 to get the square miles. So we call this constant, or the same value, the constant of proportionality. So deer per square mile is 9, and the constant of proportionality is 9. So is that a coincidence, or will that always be the case, that the unit rate and the constant of proportionality are the same? Well, we will come back to this question later. Okay, so is it a coincidence that they end up being the same number or not? All Alright, we could add the unit rate to the table so that we have 1 square mile in the first column and 9 in the second column. So go ahead and add 2 more columns to your table. Add that the square miles would be 1, and in the second column that 9 would be the number of deer. And you would notice that for each row it would be the same. So does that help to guide your decision about the relationship between the unit rate and the constant of proportionality? So what do you notice about the relationships between the 1 square mile and the number of deer, 9, in the second column? What do you notice between our first set of data and these 2 additional columns? Again, you can derive any guess or hypothesis, and we will see if your hypothesis holds true as we move through more examples. Alright, now on to your lesson worksheet. Let's go ahead and complete what we started. The unit rate of deer per 1 square mile is, and you should have written down 9. So it's 9 deer per 1 square mile. Our constant of proportionality is also 9, and when we talk about constant of proportionality, we symbolize that as the small letter k. That's what we'll be using to take the place of constant of proportionality, since it's such a long word. So we're going to use the lowercase k, so in this case constant of proportionality, k is equal to 9. So the meaning of constant of proportionality in this problem, what is 9 representing? So write it in a sentence format. What is the meaning of the constant of proportionality in this problem? You should have that there are 9 deer for every 1 square mile of forest. That's what the constant of proportionality is. Alright, so now let's apply that. Use the unit rate of deer per square mile to determine how many deer there are for every 207 square miles. So now you're going to do some math here. Go ahead and write that out and then continue the video when you have come up with an answer. Alright, you should have 9 times 207, because it's 9 deer per square mile times 207 miles, or square miles, and that would give you 1,863 deer. Right, use the unit rate to determine the number of square miles in which you would find 486 deer. So go ahead and use your unit rate and the number of deer and come up with the square miles. When you have calculated that, go ahead and continue the video to check your answer. Okay, you should have 486, because that's the number of deer, divided by 9, because it's 9 deer per square mile, and that would give you 54 square miles. So, do conservationists need to be worried? Be sure to support your answer with mathematical reasoning about rate and unit rate, and write your explanation underneath what you just did for part D, which was the numbers there. So go ahead and do that part. Again, there's no right or wrong answers. It's based on the evidence that we just came up with. Go ahead and write a few sentences explaining your answer, and then continue the video. Right. So, on your lesson worksheet, highlight the vocabulary in the box. You should see some vocabulary on constant of proportionality and unit rate. Once you've done that, then copy or write down the important pieces of information in your math journal. Make sure you include the vocabulary words and definitions, and then summarize the description of constant of proportionality. Make sure you do this in your own words, because it will be more meaningful for you. When you have completed this step, then go ahead and continue the video. Alright, so remember that in the example with the deer population, we are looking for deer per square mile. So the number of square miles could be defined as X, and the number of deer could be defined as Y. So the unit rate in deer per square miles is 144 divided by 16, or in this case, that simplifies to 9. Remember that X, or the number of square miles, that is our independent variable, so we can pick however many square miles we want to use or calculate, but Y is dependent. Okay, so the number of deer is dependent on how many miles we pick. So that's why deer is considered the Y value, and the number of square miles is considered the X value. So the constant of proportionality, again symbolized by K, is 9. The meaning in the context of example 1 is there are 9 deer for every 1 square mile of forest. So how are the constant of proportionality and the unit rate alike? Well, they're the same. They both represent the same ratio, or the same number, that is the value of the ratio of Y to X. And in this case, again, the number of deer per square mile. We don't want to know how many square miles there are for deer. We want to know how many deer there are for square miles. All right, go ahead and complete examples 2 and 3 on your lesson worksheet. Go ahead and pause the video and do that, and then continue the video to check your answers. All right, here is the answers for the first example, or actually example 2. Go ahead and check your answers, and then when you're done, continue to the next answer. Okay, here is example 3, French cooking class. Now for A, let me point out that, remember that it says considering the amount of eggs necessary to make crepes. So again, eggs is dependent on how many crepes we want to make. So crepes is our independent variable and eggs is our dependent variable. So that is why eggs is the Y value and crepes is the X value. So it will be eggs to crepes instead of crepes to eggs. So if you need to make that change or that addition to your answer, please make sure you do that. All right, so to summarize, what is another name for the constant that relates the measures of two quantities? Well, it's called the constant of proportionality. And how is the constant of proportionality related to the unit rate? Well, as you should know, they are the same. So the unit rate and the constant of proportionality are one and the same thing. All right, we'll see you in class.